guys, so today we're going to work on a stereochemistry and we're going to be assigning RNS to a couple molecules and then we're going to move to Fischer projections. So I'm going to start with something relatively easy. We have this molecule over here. And now we can determine the stereogenic center in this molecule. Since we have this carbon here, which doesn't have 4 similar groups around it, then this is our stereogenic center. Now, assigning the priority to the groups around that carbon, we'll see that this OH group has an O, versus here we have carbons attached to this carbon, so oxygen gets the first priority. Then we have this carbon here, which is double bonded to oxygen plus another oxygen, versus this carbon that is only attached to 3 hydrogens. So this gets the second priority and then the third. Now connecting the priorities, we'll get a clockwise arrow, meaning that our stereogenic center has the R configuration. However, our lowest priority, being the hydrogen in this molecule, is out of the page, not to the back. Therefore, we have to reverse the configuration, and this is S, not R. Now, the next molecule that we want to take a look at is a cyclic molecule. I'm going to be drawing it here. Here we have a 6-membered carbon ring. We have this NH2 here, and then a CH3. I'm going to be drawing the oxygen to the back of the page, but usually they're not drawn. I'm just drawing it so that I could show you the stereogenic center. We have 2 stereogenic centers here in this molecule, but we're only going to be assigning RNS to this stereogenic center. So we see that here we have a methyl group, but going here we have carbons that are attached to more carbons. And we see that from going from this side, we reach the NH2 group before going from this side. Therefore, this side gets the first priority, then it's this side, and then the third one is here. And that makes our arrow something like this. And that looks like R, and it is R because hydrogen is to the back. So I'm going to write R here. And the next molecule that we have, we're going to be dealing with a couple double bonds and triple bonds, which is kind of tricky. Here we have the C, CH, and then hydrogen. This is our stereogenic center. Looking at the groups, we have a triple bond carbon here, and we know that whenever we have a double or triple bond, we have those phantom atoms that are not drawn, but we're going to have carbons here. So comparing this group and this group, we have carbon, but then attached to this carbon, we have another carbon triple bonded. Here we have oxygen. Oxygen has a higher atomic number, therefore it gets the first priority. Doesn't matter this one is triple bonded, the fact that here we have an oxygen gives it the priority. So 1, and then comparing these two, it's obvious we have a triple bond versus a second bond, so it gets the second priority and then the third priority. Therefore we go like this. And we have it going counterclockwise, therefore it should be S, and hydrogen is to the back, so the real assignment is S. Now the last molecule that we have is this molecule that I'm going to be drawing for you. It's penicillin, and it's quite a giant molecule, but just gonna draw it for you, and then we're gonna assign some R's and S's to the stereogenic centers that we have in penicillin. Okay, so as a practice, you can go ahead and determine this. You can pause the video here and determine the stereogenic centers. I'm going to tell you that penicillin has 3 stereogenic centers, here, here, and here. Now assigning RNS, we'll start with the one to the left here. We have nitrogen versus carbon and carbon. We know that nitrogen has a higher atomic number, therefore it gets the first priority. Then comparing this carbon, these two carbons, we have a sulfur attached to this carbon versus here we have carbon double bonded to oxygen. Now, once again, as I was explaining it in the previous example, the only thing that matters is atomic number. So sulfur has a higher atomic number, therefore it gets the second priority. Here 2 and then 3. The arrow looks like this, and the hydrogen is to the back because the nitrogen is a wedge and it's coming out of the page. Therefore, it's clockwise, looks like R, it is R. Here we go. And then assigning RNS to this stereogenic center. Here we have sulfur versus nitrogen versus carbon. It's obvious sulfur gets the first priority, then nitrogen, and then the carbon here. So it looks like this. Is it clockwise? Yes, it is. It should be R because hydrogen is to the back. Here we go. Then the stereogenic center here to the right, we have nitrogen versus carbon and carbon. Nitrogen gets the first priority. Then comparing these two carbons, we have carbon double bonded to oxygen. Here we have carbon attached to sulfur. Once again, sulfur gets the first priority. So 1, 2, 3. Looks like this. Should be R because it's clockwise, but notice how this is going into the page. Therefore, the hydrogen being the least priority is coming out of the board. So it should be S. Okay, now I'm just going to highlight these R's and S's so that you know which are the assignments. And yeah, here we go. Next thing, we're going to be looking at Fischer projections. Okay, so I'll do a quick intro on this one. If we have a carbon here, then we have these horizontal and vertical lines, like a plus sign. And here we have A, B, C, D, doesn't matter what they are. The horizontal ones are the ones coming out of the page. So these are the wedges, and then here to the back of the page, you have A and C. They usually put the hydrogen in the place of B or D. Therefore, you usually have to reverse the configuration that you assign, but that's not always the case, but it usually is. So we're going to be looking at two examples here. First, we have this molecule. Okay, so once again, we have two stereogenic centers. I'm going to draw this CO2H group out so that you can visually see it. I suggest that you do the same. So it's a carboxylic acid and it looks like that. It's a carboxyl group. Assigning RNS to the one on top, we have oxygen versus carbon, so oxygen is the first priority. Between these two carbons, here you have carbon attached to oxygen, double bonded to another O. Here you have oxygen, then it's attached to another carbon. So since we have two oxygens here that have a higher priority number, we're going to assign this the second priority, then the third one is here on the bottom. So we have it looking like this, and it's clockwise, so it should be R, but notice how H is coming out of the page, so we have to reverse it, therefore it's S. Then the one on the bottom, we have OH here, first priority. Comparing these two here, you have carbon attached to OH, carbon attached to carbon, and attached to OH. So here, up until this point, they're the same, but then you have a carboxyl group attached to the one on the top, so this one gets the second priority. The third looks like this. Should be S because it's counterclockwise, but once again, we have the hydrogen coming out of the page. Notice that how here the horizontal lines are coming out of the page, so we should reverse it, therefore we have R. The next one we're going to be looking at is a similar molecule, just for the sake of practice. H. Okay, once again, I'm gonna draw this one out. It's an aldehyde group, a carbonyl, sorry, H, not O. Okay, so we have two stereogenic centers. For the one on the top, we have OH, gets the first priority. Here, comparing the C double bonded to O, here we have C, single bonded to oxygen. Therefore, the one on the top gets the second priority, then the third. Goes like this. Looks like S because it's counterclockwise, but hydrogen in the front, so it's R. Then for the one on the bottom, OH gets the first priority. Between these two, remember this CO2H group, it's the carboxylic acid. So I'm going to draw it like this. And so here we have carbon double bonded to oxygen, single bonded to another oxygen, versus here we have carbon only single bonded to an oxygen and single bonded to a carbon. So this one gets the second priority, the third one on the top looks like this. Clockwise should be R, but hydrogen is to the front, so should be S. And once again, I'm going to highlight the R's and S's here so that you can see all of them more clearly. And yeah, so whenever they ask you to compare Fischer projections and have you tell them if they are diastereomers and enantiomers or not related, you can always look at the formula, and if it's the same, you can compare the stereogenic centers. If they're flipped, then they're enantiomers. If one is different, then diastereomers, and so on. Alright, thank you for listening to this video, and bye!